Alright people, this is your 8-4 ellipses concept guide. Ellipses are similar to circles, but they're also different, a little bit harder. But as you go through this, you'll see it's not too very hard. There's going to be a lot of stuff that you need to write down, so please hit pause when you have to write down the different diagrams. An ellipse is a set of all points x, y in a plane such that the sum of the distances from two fixed points called foci in the plane is equal. An ellipse has two axes of symmetry. The longer one is called the major axis, the shorter one is the minor axis. Alright, that is the key right there. The longer one, the bigger number, is the major axis. The shorter one, the smaller number, is the minor axis, okay? So below you see two standard forms of an ellipse. You have one where x is first, one where y is first. The key there is that a squared is underneath x squared in the first one right here. We got a squared there. And here we got a squared underneath the y, okay? So the first formula, that would be a horizontal ellipse, meaning it would be wider than it is tall. The second form would be a vertical ellipse, which means it would be taller than it is wide. Alright, again, when you look at the equation of an ellipse, the bigger number is going to tell us whether it's going to be vertical or horizontal. If you look up at the top up here, I'm not going to give it a center, but if you had x squared over 9 plus y squared over 3 equals 1, well, this is going to be a horizontal ellipse because 9 is the bigger number and it's underneath x. X-axis, horizontal, okay? If, right next to it up here on top right, if I had x squared over 3 plus y squared over 9 equals 1, that would be a vertical ellipse. Alright, that's because, hold on, writing this down, because the bigger number's underneath y. Y, vertical, up and down. Alright, that's what it's telling us. Okay, if you notice too, on both I had x first. Okay, you will see this both ways. In the formula below, I switched y squared first on the vertical ellipse. You'll see it that way. Sometimes people will keep x first the whole time, and the bigger number tells us whether it's vertical or horizontal. So you just have to look for that. People get all caught up in the a squared, b squared. That's just telling you in the formula which one's bigger. Okay? Once we get into the actual problems, the bigger number tells us whether it's a vertical or horizontal ellipse. Okay? We'll go over that more on Tuesday. I'm sure some of y'all will be confused. Don't be afraid to talk to each other about it. Okay? But there you get A is always bigger than B. Okay? So, I went ahead and drew a horizontal ellipse right there. I erased that stuff. We're going to write what goes next to that below it. First, you got a horizontal ellipse. Okay? I drew in C there. C is the foci. Alright. We will talk about the foci. I will go over it during the problems, but it would just be extra credit on the quiz or test if you get the foci correct. Okay. Then I'll also have a drawing of what our vertical ellipse would look like. Key down here, we have major axis length is 2a, and we have minor axis length is 2b. Okay. The full length is 2a. The full or the full major length is 2A. The full minor length is 2B. Okay. This would be a good point to hit pause and to mark this stuff down. All right. Alright, once you hit unpause, we'll go down to the bottom. If you look at, we still have horizontal on the left, vertical on the right. Okay, center is the same for both, H and K. That's our formula to get the foci. Length of major axis, length of minor axis are the same. Okay. Again, another good point, another good place to hit pause. Instead of me just sitting here for like 3 minutes waiting for you to write this down. I'm not going to do that. Hit pause. Alright, so hopefully you've unhit pause. Next section, we are going to write our equations of the ellipse. The first example, we have the endpoints of the major axis are at -7, 2, and 5, 2. Endpoints of the minor axis. All right, -1, 0, and -1, 4. Well, a little shortcut is look at our major axis. We have 2 2's there, right? If you look at our minor axis, we have 2 -1's. Ooh. All right. That's telling me that my center is going to be -1, 2. I can also do my midpoint formula, which would give me -1, 2. But I like the shortcut better. That always works on ellipses. Okay, provides less work to do. Alright. So I know that I'm going to have x plus 1 squared plus y minus 2 squared equals 1. So now I just need to find a squared and b squared. Well, I know that that's going to be, alright, so I usually do that part on the board. Alright, so I'm going to write this in. So, I got 36 and 4. If you look at my major axis endpoints, I know that it's going to go underneath x because the x values are what's changing. Alright, that is what's changing. With those 2 points, I can do the distance formula. That is fine. It will work every single time doing the distance formula with those 2 points. Alright, but a little shortcut would be if you were looking on a graph from -7 to 5 would give me 12. Also, remember, distance is always positive, right? So even though that's a -7, we can do 7 plus 5 equals 12. Well, that would be the full distance, all right? Like we said earlier, that would be 2a. So that means a would be 6. So 6 squared. A squared is what gives me that 36 there. All right, so same thing with the minor axis. Okay, same thing with the minor axis. I know it's going underneath the y because the y values are the 2 values that are changing. This is a little easier with 0, but that distance from 0 to 4 gives me 4. But remember, that's 2b, the full length. So that means b is 2. So b squared gives me that 4 below right there. And I have my equation of the circle. Okay. Again, for that minor axis, you could use your distance formula. All right, that would have given you 4, and that would have been fine. Okay. All right, need to go back and watch that. That's fine. All right, problem number 2. We have a major axis of 8 units long, and it's parallel to the x-axis. Well, if the major axis is parallel to the x-axis, that means it's going to be horizontal, side to side. So, and I was already given my center at the beginning. That's nice. I got that going for me. So all I need to find is a squared and b squared. Well, 2a is 8, so a is 4, so a squared gives me 16. Alright, well again, my major axis was parallel to the x-axis. I know it's horizontal. I know it's going underneath x. Okay. Well, so for y, if my minor axis is 2 units long, it means 2b equals 2, so b equals 1. So b squared is 1. Alright. Don't worry about problem number 3. Let's look at problem number 4. So again, my little shortcut. Alright, I can do my midpoint formula to get my center. Alright, or you can just look at the 3's aren't changing, so it's 3, and the y's aren't changing, so it's 3, negative 6. Again, that's what I do. You don't have to do that. Alright, next. The endpoints of my major axis are from 2 to negative 14. Alright, so the y values are what's changing, so that means this is going to be a vertical ellipse. The 2 and the negative 14, it's in the y, it's in the y spot of our ordered pair. Alright, so it's going to go underneath the y. Well, again, we can use the distance formula of those 2 points. You can do that, that's fine. That will work. Easiest thing to do, though, is to add 2 and 14 together, which gives you 16. Okay? Let me see where I went with this. I know we got that there. Alright, I'll go back and rewrite this down. Okay, so I'm going to write this in the column below and show you how that works. So again, circled in blue right there, I've got 2, and then a negative 14, distance is always positive, so that will be positive 14 gives me 16. Well, that's 2a. So then I get a is 8, and a squared is 64. And remember, that goes underneath the y because our major axis was given. The y values were what's changing. If you look at the endpoints of the minor axis, the x values are what's changing. And we have negative 1 to 7. Well, distance is always positive, so that's going to be 1, positive 1, plus 7. And that gives me 8. So 2b, so 2b is 8, divided by 2. b equals 4. So b squared would be 16. Alright, so that's what you do there. I'm going to erase that out of this column right here. Alright. Last, number 5. Again, minor axis is 6 units long, parallel to the x-axis. That's just like above, except this is talking about the minor axis. So that means this is going to be a vertical ellipse. The major axis is 12 units long, center's at 6,1. Well, that info is given. It gave us our center. That's nice. Going to plug that into our formula. Well, it gave me that my major axis is 12 units long. 2a equals 12, so that means a equals 6. Means a squared equals 36. Alright. I knew it was underneath y because it told me my minor axis is parallel to the x-axis. So my minor axis is horizontal. Then it's 6, so that gives me 2b is 6. So b is 3, so b squared gives me 9. Okay. Alright, these are a little more difficult than circles. Just keep rewatching them. You'll eventually get the hang of it. Wednesday we'll go over it more. Alright, last part. Number 1. Alright, so our center at both is 0, 0, so we can mark that point. Well, a squared is 9, so that means a equals 3, or square root of 12. My bad, a squared is 12. Sorry, looking at the wrong thing. So a equals square root of 12. So if I took the square root of 12, that'd be like 3.5. Since it's underneath the y, I'm going to go up 3.5 and down 3.5. Then I got b squared is 9, so b is 3. Since it's underneath the x, I'm going to go right 3, left 3, and I get my ellipse. That one's pretty close to a circle, right? But it's not. The measurements are a little off. We have a vertical ellipse. Alright, example number 2. I got a squared is 25. So a is 5. Again, my center is 0, 0. Alright, so since a squared is under x, that means I'm going to go right 5 and left 5. And b squared, the smaller number, is underneath y. So b squared is 4. So b is 2. So I'd be up 2, down 2. And I have my ellipse. Alright. So I ended up doing the foci on both of these. The foci is always on the major axis. Okay? Always on the major axis. Again, this would just be extra credit. Let's see the foci on each of those graphs, always on the major axis. So it's the ellipse concept guide. BT's got a homework sheet for you. Let's go ahead and work on that, and we'll go over all this again next class. Thank you, and good night.